In this video, we're going to discuss transformation, specifically scaling. Scaling means that you're stretching or compressing a function, you're making it wider or narrower. The first type of scaling we're going to discuss is when you stretch a function vertically. Let's imagine a vertical stretch. Let's say we have a basic function y is equal to x squared, a parabola. When we stretch it vertically, what we're doing is we're pulling the function up and we're pulling the function down. So what ends up happening is our function gets narrower and it ends up looking something like that. So in order to do that, in order to stretch a function vertically, we multiply, let's say we have the basic function y is equal to f of x. We multiply the whole function by some constant that's greater than 1. So let's say a is our constant. When we stretch our function, we get y is equal to a times f of x. And let's say our function is y is equal to x squared. In order to stretch it vertically, we're going to multiply this x squared function by some number that's greater than 1. So we're going to multiply, let's say, by 2. Y is equal to 2x squared. And let's graph these two. Y is equal to x squared is going to be the original parent function, and y is equal to 2x squared in red is the transformed function. It's the original function, and that is the scaled function. Notice how it gets narrower because we stretched it up and down. Let's say we had a more complicated function. Let's say we had the function y is equal to x squared plus x minus 1. If we wanted to stretch this function vertically, we would have to multiply each term by whatever a is. Let's say we're scaling it by a factor of 3. We would do y is equal to 3 times x squared plus x minus 1. And we could distribute this 3, and it has to go over all the terms. Y is equal to 3x squared plus 3x minus 3. And let's graph these two. Our original function was y is equal to x squared plus x minus 1. And their scaled function was y is equal to 3x squared plus 3x minus 3. And zoom 6 for zoom standard. That's our original function. That's our scaled function. Notice how it was stretched up and down, and therefore it got narrower. Let's move on to vertical compression. A vertical compression would look something like this. Let's say we have our basic y is equal to x squared function. A compression means that we're pushing it up from the bottom and pushing it down from the top. We're pushing it in towards itself. Therefore, we're going to cause it to get wider. And that would be our new function. In order to do that, we would have to multiply the whole function by some number a, some constant that is less than 1. But a also has to be greater than 0. Let's look at this. So let's say we have y is equal to f of x. In order to compress it vertically, we would multiply this function f of x by, let's say, 1 over 2. And let's look at an example. Let's say we have y is equal to x squared as our example. We have to multiply it by some number a that's greater than 0 and less than 1. So y is equal to 1 over 2x squared. And let's graph these two. Our original function, y is equal to x squared, and our new function, y is equal to 1 over 2x squared. And zoom 6. It's our original. That's the compressed function that gets wider. Let's look at one more example. Let's do a more complicated example this time. Let's say we have y is equal to x squared plus x minus 1. We'll use the same one from before. In order to compress this function, we'd have to multiply each term by some number that's greater than 0 and less than 1. We could use a half. Y is equal to 1 over 2 x squared plus x minus 1. And we could distribute this. We don't need to, but we can. So y is equal to 1 over 2 x squared plus 1 over 2x minus 1 over 2. And let's graph these. So the basic original function is y is equal to x squared plus x minus 1. And the transformed function is y is equal to 1 over 2x squared plus 1 over 2x minus 1 over 2. The blue one is the original one, And the red one is the new one. Notice how it got wider because we pushed up the blue one from the bottom and pushed it down from the top. Next, we're going to look at horizontal stretches and compressions. We're first going to look at a horizontal stretch. A horizontal stretch would be, let's say we had this parabola, the same one we've been using all along, a basic y is equal to x squared parabola. A horizontal stretch, what that would do is it would stretch it out from the right and stretch it out from the left, and it would end up getting wider, like that. And how would we do this? We have to multiply just the x term, just the x part of the function, by some number a that's greater than 0 and less than 1. So let's say we have our function y is equal to f of x. In order to stretch this horizontally, we would switch this to y is equal to f of a times x. Notice how this is different than what we had before when we were doing vertical stretches and compressions. Before, we multiplied the whole function by the a value. For a horizontal stretch, we're just multiplying the x part of the function by some a number. So let's say we have the function y is equal to x squared, and we wanted to stretch this horizontally. We can stretch this horizontally by replacing the x with, let's say, 1 over 2x squared. We multiply just the x by the 1 over 2. And let's graph these two. Y is equal to x squared, that's the basic function. And then y is equal to 1 over 2 x squared. Zoom 6 for zoom standard. It's the basic original function. That is the stretched function. Notice how it got wider because we pulled it out from the right and pulled it out from the left. Let's look at a more complicated example. Let's say we have y is equal to, we'll use the same one from before, y is equal to x squared plus x minus 1. In order to stretch this horizontally, we have to replace each of the x terms with 1 over 2x. This becomes y is equal to 1 over 2x squared plus 1 over 2x minus 1. Notice how when we did a vertical stretch and compression, we multiplied the entire function, even the constant, by the factor that we were stretching or compressing by. When we're doing horizontal stretches and compressions, we are just multiplying the x terms in the function by the 1 over 2. So let's graph these two. The original function was y is equal to x squared plus x minus 1. And the new one is y is equal to 1 over 2 x squared plus 1 over 2x minus 1. Zoom 6 for zoom standard. That's the original. That is the stretched version of the function. Now we're going to look at horizontal compressions. A horizontal compression would look something like this. Let's say it's our basic x squared function. When we're compressing a function horizontally, we're pushing it in from the right and pushing it in from the left. And it ends up getting narrower. It would look something like that. In order to do this, we have to multiply just x by some number a that's greater than 1. So let's say we have our function y is equal to f of x. To compress this function horizontally, this would become y is equal to f of a times x, where a is greater than 1. Let's look at an example. Let's say we have y is equal to x squared. In order to compress this horizontally, we would multiply just the x by, let's say, 2. So this becomes y is equal to 2x squared. We're squaring the whole x term, and the 2 is now attached to the x. So let's graph these two. The original is y is equal to x squared, and the new one is y is equal to 2x squared, and zoom 6 for zoom standard. The original, and that is the compressed function. Notice how it got narrower. Let's look at the more complicated function. We'll use the same one as before. Y is equal to x squared plus x minus 1. And when we want to compress this horizontally, we're multiplying just the x terms by, let's say, 2. So this becomes y is equal to 2x squared plus 2x minus 1. Notice how we didn't do anything to the negative 1. It's a constant and it does not have an x. Let's graph these two. The original y is equal to x squared plus x minus 1. And the new one, y is equal to 2x squared plus 2x minus 1, zoom 6 for zoom standard. The blue one is the original, and the red one, notice how it got narrower because it got compressed.